In this video, you're going to be introduced to the fundamental principles of occupational epidemiology. I realize that not everybody who's watching this video will have taken coursework in epidemiology, so I'm just going to review some of the reasons why we do epidemiology in the first place. Pictured on the far left is a bill of births and deaths occurring in London in the 19th century. This is a practice that began in the 15th century when the bubonic plague was ravaging the population of England. Keeping track of births and deaths in the population is a piece of epidemiology. It's useful for a whole host of reasons. We use epidemiology to identify vulnerable populations, people who are at particularly high risk of adverse health outcomes. By identifying vulnerable populations, we can use our prevention dollars efficiently and effectively to target the people who are in the greatest need. We calculate the rates of diseases and injuries in epidemiology to understand whether a particular public health problem is getting worse or whether it's getting better. One of the key functions of epidemiology is to identify what causes disease and injury in the population. There are a couple of reasons for doing this. By identifying causes of disease and injury in the population, we can identify opportunities for prevention, and by understanding the fundamental processes of disease and injury, we can develop better treatments as well. And last but not least, epidemiology helps us determine which interventions work and which ones don't. Epidemiology helped establish airbags as an effective way at preventing motor vehicle crash deaths, and condoms as an effective method to prevent sexually transmitted infections in populations of people. So what makes occupational epidemiology unique? Well, there are a few things. One, as the name would imply, we focus on workers and workplaces, and I'll give you just a few reasons why that might be a useful thing to think about. Occupational epidemiology studies tend to have very rigorous exposure assessment methods due to partnerships that we form with a whole cadre of scientists that refer to themselves as exposure scientists. In terms of epidemiology study designs, all epi-study designs are useful, including randomized control trials and cross-sectional designs. But occupational epidemiologists tend to have really nice cohorts. In any discussion of epidemiology, it's important to talk about potential sources of bias. In occupational epidemiology, we have a particular kind of bias known as the healthy worker effect. So here are just a few reasons to think about work and health. Most occupational epidemiology studies focus on hazardous working conditions that might lead to disease and injury. It doesn't take a great deal of imagination to see how working in construction or oil and gas or coal mining or logging might result in acute traumatic injury. It takes a little bit more imagination to think how these jobs might lead to long-term, potentially fatal chronic diseases. But each one of these occupations has a set of occupational illnesses that are associated with them. For instance, you may have heard of black lung disease, coal workers' pneumoconiosis. Construction workers and workers in the oil and gas industry are often exposed to high levels of silica. Silica is a known cause of silicosis, which can be fatal, and high levels of exposure to silica on the job can lead to lung cancer as well. Workers in all of these jobs are exposed to very high levels of noise, which of course causes noise-induced hearing loss. On the other hand, just to complicate things a little bit, employment can be good for health too. We know, for instance, that in the United States, historically, health insurance has been tied to employment, so that people who are employed are much more likely to have access to health care than people who are unemployed. Strange as it may sound, each one of these jobs pictured here at right involves high levels of physical activity, which is something that's severely lacking in a lot of knowledge-based work nowadays. And of course, employment is related to income, which is used to purchase food and housing and all sorts of other things that are important to a healthy life. Which gets to a third point, which is that work is a social determinant of health. You may be wondering why you're looking at a Grecian urn. Well, depicted on this urn are slaves from ancient Greece who are harvesting olives. Maybe not surprisingly, these slaves were at the bottom rung of the social hierarchy in ancient Greece. These slaves had really hard lives, and their work negatively impacted their health. So if you're somebody who likes to think about the social determinants of health, don't forget about work and employment and what a person's job might say about their standing in society. Like I said, one of the key functions of epidemiology is to identify causal relationships between exposures and outcomes. We want to know what causes disease and injury from occurring. Epidemiologists aren't the only scientists who are concerned with this, but it's central to our discipline. We go about it by identifying statistical associations between exposures and outcomes in human populations. We compare people who were exposed with people who were unexposed. We compare people who have cancer with people who don't have cancer, and we try to figure out how they're different. And while a statistical association between an exposure and an outcome doesn't necessarily mean that the relationship is causal, if a study's done well, a causal relationship will be reflected in a statistical association. Here are a few persistent, established occupational hazards. Occupational epidemiology was used to identify asbestos as a cause of mesothelioma, an aggressive and often fatal form of lung cancer. Occupational epidemiology found that benzene is a cause of leukemia and that coal dust is a cause of coal workers' pneumoconiosis, otherwise known as black lung disease. And just as occupational epidemiology was used to establish those as hazards in the workplace, occupational epidemiology research is now looking at emerging hazards. In studies of rodents, exposure to particular types of nanoparticles resulted in the same form of aggressive lung cancer as asbestos exposure. We haven't seen studies in humans, we haven't seen epidemiology studies, so we don't know if that relationship, if exposure to those same nanoparticles would produce disease in humans. But this is an active area of occupational epidemiology research. Occupational epidemiologists are also exploring links between shift work, for instance working at night, and cancer risk. Occupational epidemiologists are trying to understand the contribution of sedentary work to the growing obesity epidemic in this country. And finally, like I said, epidemiology can be used to evaluate the effectiveness of interventions. Occupational epidemiology has been used to look both at the effectiveness and the cost effectiveness of body armor at preventing gunshot deaths among police officers. Occupational epidemiology has found that those back belts commonly worn by workers in loading docks and warehouses are ineffective at preventing back injury. And finally, occupational epidemiology has found that inspections by occupational safety and health regulators are effective at reducing injury and illness rates. But regardless of whether we're looking at an intervention or a possible hazard in the workplace, a fundamental question that epidemiologists think a lot about is how we measure exposures and outcomes so that we can test those statistical associations. Occupational epidemiologists partner with an army of exposure scientists to develop very rigorous exposure assessments in occupational epidemiology studies. Industrial hygienists develop and implement methods to measure exposures to chemicals, to noise, and to biological exposures. Ergonomists develop methods of measuring musculoskeletal risk in the workplace. Health physicists are experts at measuring and controlling radiation exposure on the job, and occupational health psychologists develop methods to measure workers' exposures to stress. Pictured here on the right are a few of the tools that these exposure scientists use. The worker in the blue coveralls and the hard hat is wearing an air sampling pump. The air pump draws air through this sampler, which contains a filter, and that filter, as air is drawn through it, captures chemicals or particles that the worker is breathing in. And so by analyzing that filter, industrial hygienists can make a very well-informed guess and estimation not only of what that worker might be breathing in, but how much he is exposed to. Next to that image is an industrial hygienist who's testing the effectiveness of a respirator. And below those two images is a photo of an inclinometer, which is a device that ergonomists use to measure the torso's position relative to the ground in order to assess the risk for back injury. So that's how occupational epidemiology studies measure exposure, by working with exposure scientists. How do occupational epidemiologists measure outcomes? Well, like other areas of public health, we conduct surveillance. There are a few ways that we have of tracking non-fatal injuries and illnesses. The Survey of Occupational Injuries and Illnesses, again administered by the BLS, is one method. We also use workers' compensation insurance records, which are governed by state-specific laws. And OSHA 300 logs are records that employers keep of particularly severe occupational injuries and illnesses. I should mention that many of these systems that we use undercount and underestimate the true burden of occupational injuries and illnesses in society. Large cross-sectional surveillance surveys, like the National Health and Nutrition Examination Survey, sometimes ask questions about occupation, what types of jobs the respondents have. By analyzing these large data sets, occupational epidemiologists can test for associations and explore relationships between occupation and other diseases not traditionally thought of as work-related, diseases like obesity and diabetes. And finally, occupational health surveillance can be done through cohort-based surveillance. Workers in the same occupation or in the same industry often share similar exposures, and by tracking them over time, we can better understand the relationships between their exposures on the job and health outcomes they may experience. There's a national screening program for coal workers' pneumoconiosis, and there's a national surveillance program for former Department of Energy workers who helped build nuclear weapons during the Cold War and who were exposed to hazardous chemicals and radiation on the job. And like other areas of epidemiology, sometimes cohorts are established or defined for specific studies. An example of this would be the Whitehall studies in Great Britain. When it comes to analyzing the data that gets collected, linking exposures and outcomes, all study designs, all epidemiological study designs can be used to study workers, including randomized control trials and cross-sectional designs. But cohort designs are particularly common in occupational epidemiology. Workers experience a range of exposure levels, from very high levels of exposure to very low levels of exposure. And by taking a group of people who are similar in some ways, but whose exposure levels vary, occupational epidemiologists can explore dose-response relationships between exposures and outcomes. Also, cohort study designs are particularly common because workers are already organized into social groups, and sometimes this social organization is accompanied by records of employment. This sort of administrative bookkeeping can actually be really useful for occupational epidemiology studies, as you'll see in one of the case study videos associated with this lecture. Standardized mortality ratios are one particular analytic tool that are used to analyze cohort data, and because cohort study designs are particularly common in occupational epidemiologists tend to use standardized mortality ratios a little bit more often than other types of epidemiologists. While standardized mortality ratios can be useful, they are prone to bias, which we'll talk about in another video connected to this lecture. Speaking of bias, the healthy worker effect is a particular form of bias that can be present in occupational epidemiology studies, though it isn't always present in occupational epidemiology studies. So here's the issue. Sometimes epidemiologists want to compare cohorts of workers to the general population to see if those workers have elevated risk for certain diseases or certain injuries. But there's a problem. It's hard to make comparisons between cohorts of workers and the general population because people who work are generally healthier than people who don't work. And this happens for a couple of reasons. One is that healthy people are selected into the workforce. A lot of job descriptions, for instance, will say that you can't work in this job unless you're able to lift 50 or 100 pounds. On the other hand, unhealthy people are selected out of the workforce. So sometimes people start off working and they're perfectly healthy, but whether it's due to a work-related injury or illness or some other health issue, sometimes they have to leave the labor force. They can no longer perform the necessary duties of the job. And related to this, depending on how long the study is, if the population is followed for long enough, the people who are present at the end of the study tend to be healthier than the people who are present at the beginning of the study. So in summary, these are just the principles. This is sort of a broad overview. Occupational epidemiologists pay close attention to the health effects of work in workplaces. We work with a cadre of exposure scientists to develop studies that have rigorous exposure assessments. We use all of the tools in the epidemiological toolkit, all various forms of study designs, but we use some designs and some metrics more than others. And finally, the healthy worker effect is a source of bias particular to occupational epidemiology. And that does it for the summary. There are a few other videos that you're going to have to watch as part of this overview of occupational epidemiology, but I hope that that was informative and useful.